This online science video is powered by Science Clinic and proudly supported by UNISA's College of Science, Engineering and Technology. In this video, we will discuss the properties of magnetism. So what exactly is magnetism? It's this weird physical phenomenon that just produces attractive and repulsive forces. And yes, a magnet is basically an object with a pair of opposite poles called north and south. It's that simple. There are three elements with magnetic behavior which we call ferromagnetism, and these are iron, nickel, and cobalt. All ferromagnetic materials contain magnetic domains, and when these magnetic domains line up, such as in this case, you have a south pole as well as a north pole. When the magnetic domains all point in different directions, you have an unmagnetized material. This material, however, can be magnetized by simply applying a current through it, aligning all the little domains in one direction. Magnetic domains also help to explain that when a magnet breaks, such as this one, you have two individual magnets, each still containing a south pole and a north pole. And the reason for this is because they still contain their magnetic domains, pointing individually in the same direction. A magnetic field is a region in space where another magnet or ferromagnetic material will experience a non-contact force. So usually they say that a magnetic field is invisible, but when you simply throw some iron fillings around a magnet, it becomes quite visible. Because iron is a ferromagnetic material, the iron fillings align themselves on the magnetic field of the magnet. So the force between two magnets can either be attractive or repulsive. So a repulsive force is when you have two like poles, such as in this case two north poles. They would repel each other. Same thing with two south poles. They would repel each other. But when you have a south pole and a north pole, remember that opposites attract and they would move towards one another. The magnetic field lines around a magnet are actually extremely important because they indicate the direction as well as the strength of the magnet. The magnetic field would be the strongest where the lines are most dense. So this happens at the two poles. And the field lines occur inside the magnet as well. So not just around, flowing from north to south, but also inside. And then the magnetic field is actually from south to north. And this basically completes the magnetic field pattern around the magnet. So when asked to draw the magnetic field around a magnet in an exam, remember to always show your arrows. When we view the magnetic field lines around two opposite poles, you can clearly see the attraction that they have because the magnetic field flows from north to south. When we view it with two similar poles, we know that like charges or like poles repel each other. So here you can see that these lines are actually pushing one another away as they repel. The Earth also has a magnetic field, and it is actually so important in our everyday life since it protects us from harmful solar radiation. The Earth behaves as if it has a giant bar magnet running through it. And if you take a compass needle and you hold it in your hand, it'll actually point what we say is north. Well, this is the geographical North Pole that we are talking about. The compass needle's north actually points to the Earth's south pole because opposites attract. So the Earth's magnetic poles are actually opposite to the geographical poles. The angle between the magnetic south pole and the geographical north pole is what is known as the angle of inclination. I hope that you found this video educational. Please like us on Facebook or follow us on Twitter.